Okay, density and specific gravity. You know, it's actually kind of cool, but I don't need you to know exactly how they are derived. I just need you to know how to use specific gravity when it's given to you in a problem. But basically the density of something is the mass of whatever it is per some kind of volume. And we, of course, usually use grams per mil. Okay, you don't have to, but metric, that's what we do. So this first problem, or explanation is, what's the density of an oil for which 54.96 mils of the oil weighs 52.78 grams? So, as I've said over and over again, you guys all know that 1 mil of water weighs 1 gram. So the density of water is going to be 1 over 1, right? So that's the density of water. The density of anything that is less dense than water is going to be less than 1, as is the specific gravity. And the density and specific gravity of anything that's denser than water is going to be above 1, right? And you guys probably already intuitively knew that. So density actually has units. So it's, again, it's mass per unit volume. So in this case, we looked at this oil. It's 52.78 grams of it, and that has a volume of 54.96 mils. So its density is 0.9603 grams per mil. It's less than 1. So oil, as you know, is going to usually float on water because it's less dense than water. All right. Specific gravity is kind of another way of explaining the same thing, but it's comparing the density of one substance to something else. And what we always use is water. So the density of water is 1, right? And as is the specific gravity. So the specific gravity is defined, and again, I'm just telling you this, and I'm not going to ask you this, but it's defined as the weight of a specified volume of a substance over the weight of the same volume of water. So if we go back to that 54.96 mils of oil that we were talking about, it weighed 52.78 grams. But how much does 54.96 mils of water weigh? 54.96 grams. If you look up here, they're the same numbers here and here, but in this case we're measuring gram to gram, so those cancel out and you're left with a unitless number. It's the same number, but specific gravity is unitless. What do I want you to take away from this? Do I want you to remember that? It's cool, but and you should have some idea what's going on with specific gravity. But what I want you to know is that if you are ever given a specific gravity in a substance in the problems, which you will be on quiz number 4, I'll be back for that, think grams per mil, grams per mil, grams per mil. If I say the specific gravity of water is 1, that means there's 1 gram of water per every mil of water. If I said the specific gravity of this oil was 0.9603, that means there are 0.9603 grams of that oil per mil of that oil. Why is this going to be useful? Because you're going to have problems where you have to sort of convert from grams to mil using specific gravity. So just like when I say if you have need to use a dimensional analysis problem with a percent, you can just convert that to how many grams per 100 mils. The same thing, if I ever give you the specific gravity of something and you need to use it in dimensional analysis, so for this, in this case it's the oil, you're going to say there are 0.9603 grams of the oil per every mil of the oil. And now you've got this per relationship that you can use in your dimensional analysis as long as you make sure everything cancels out as it should be, and you are good to go. So again, down here, specific gravity can be thought of as equivalent to density when working with pharmacy calculations. Okay? I know any of you other physicists and chemists might be cringing, but just think and use grams per mil and you will be safe. So if I say the specific gravity of a substance is 0.92, you can say that there are 0.92 grams of the substance per every mil of the substance, whatever it is. If I say the specific gravity of it is 2.12, then you can just say there are 2.12 grams of this substance per every mil of this substance. So really it's just another way to convert between grams and mils and use that as another per relationship in your calculation problems. Okay? So sometimes some of the problems, like you probably saw just now, some of the alcohol was measured in grams instead of mils, even though it's a liquid. You might see things that are liquid measured in grams. But if I said, figure out how many mils of the alcohol you needed, you could figure out how many grams you need, and then if I would always give you the specific gravity, you could just convert it to mils. All right? All right, so I'm just with that, and maybe looking over some of this up above here, I'm going to go ahead and pause and let you guys do the work problems 1 through 6 and see where you get. I will be right back. You guys work. I'll take a break. You work. And I will show you how I did those problems. All right?